I hope you like it. This is how it's looking here in the back. It has no batteries whatsoever, but I put 2 wires from this board that I'm actually powering it with 4.2 volts. I don't want to, I did some tests already, so I'm keeping it lower as possible because this is the minimum it can be powered, this little circuit, this voltage regulator circuit. After beneath 4 volts it will go lower than 3 volts. So what this circuit is doing is I'm using this voltage regulator semi-D version, AMS1117. This is there. I'm powering it to 5 volts with this power traveling adapter for 5 volts, 1 amp, but I don't really need that 1 amp of it. And stay lit, motherfucker. Come on, stay on. Yeah, this is very, very stupid, extremely stupid, because it's closing automatically. I really hate it because it's doing it automatically. So this is the values, 1 kilo and 1.4 kilo ohm for the 2 resistors. To give me 3 volts, but if I'm powering it with 4 volts, if I'm powering it with 3.9 volts, it will go lower than 3 volts to 2.7, 2.5, even lower, and rapidly going down and abruptly. But after 4 volts up, so 4.2 and up, it will maintain the 3 volts on its output, very constant. I even this AMS117, come on, dude, you can do it. Come on, you fucker. So this AMS is rated to 15 volts input, but I put 18 or 20 volts and it's still doing it. Depends on the load here, what is powering, I guess. I didn't put this capacitor here. Probably I will add it in the final circuit. So right now, so this is the circuit right here. These are the pinouts for that one. And here is on the board right now is that guy there. Is it? Come on. Is that guy there? Let me put some light on it. Yeah. Is doing anything good? And that is 1 kilo there, and 1 kilo and 300. How much it was? 390. This guy. I didn't have the 400 exactly. So yeah, I put them like that. Put to ground, and Bob's your uncle, no? And it's working. It's working actually pretty good. This is the test mode right now. I was testing it, and I really want to be able to hack this light somehow. Probably I will add my own LEDs or opening it and put another button only for the LEDs themselves, because if this will this is my plan right now. I want to as you already figured it out, I will power it from this device, from this power supply with a long wire through this AMS voltage regulator, and it will stay on a lot of time. When I will plug it in the main power there, it will stay on as much as I want it to stay. Not being afraid of those very dinky batteries. These are the batteries that is having. They are pretty good batteries actually. They actually go down very slowly. But I want to have those LEDs open. This light. Come on, fucker. This light, I really want to have it because it's clear. It's fantastically clear. I love it. I love it. But with that function that is automatically turning it off is pissing me off like crazy, and I want to make it light all the time without that bypassing that auto closing function that is having, which is stupid, by the way. Is extremely stupid. Don't do automatic stuff on very important things. I understand that they did it to protect the battery life, but come on, you can do it better, if you put your heads to think a little bit. So this is my plan right now. Is in tests. This is the test. Make abstraction of this part here. This is not part of the experiment. Only this little guy is here. That's it. Without that, without that one. So only in this segment here is powering my device I have right now, and it's working absolutely fine. And I'm very happy with it. And the next step is to actually make the board with this little voltage regulator AMS1117, and drag a wire, a longer wire from this to that. Little board that will power this device. Pretty much this is it, and that will be the first step to power the device. And the second step is to somehow to hack those LEDs, and most probably I will add a button for them as well somewhere to turn on off when I want, and that's it. 2 steps I have to make. But this is the most decisive one. Powering it is the most dangerous. I'm really afraid. I mean, I'm not really afraid because I did this stuff. But if I'm doing stupid mistakes, I'm afraid to burn it out. So this is one shot, and I have to be extra mega careful not to fuck it up. So yeah, wish me luck. Wish me luck with it, and we will see each other on the other side of the project. Hopefully with good news. Thank you very much, and I hope you like it. Let's powering it up. Come on, you bastard. Little shit. It's very good. It's extremely good. I love it for if I have a lot of different resistors in one place, and all are mangled, and this is doing a phenomenal good job automatically finding the value of each resistors in those mangled so too many of them of different values, and is absolutely, I love it from this point of view. But other stuff that is doing is not that good, but for automatically finding the value of resistors is absolutely brilliant. I love it from this point of view. All right, so this is a small update. This is the layout of the board. Usually I'm doing it first on a piece of paper to see the dimensions, and then I copy it on the final cardboard here, and it's very small. It's very tiny. I put a resistor. I hope you can see it. Let's do it like this. You see it? It's put vertically there because I had to conform to a specific space, and pretty much this is it. Yeah, it's looking good. It's looking good. It's a very tiny one, and this will fit somehow there, somewhere there. And this red one is the 5 volts. This black wire is the ground, and they are actually exactly on this pin. Let me point with my trusty knife here. So on this pin here, as you can see here, it's like this. This is the in, and here is the in, the plus 5 volts on that specific pin, and here is the ground that is linked there. For that resistors. I didn't have 100 and not 100, 1.4 kilo. What I had either 1 kilo and 400, but I don't have, or 1.3 kilo and 100 ohms, which I had, and together they made 1.4, exactly 1.4. So this that's why I have 2 resistors here. That 1.3 here and 100 ohms there, and together they make 1.4. And to the ground, this guy here, from the adjustment pin to the ground, and this is the ground with the wire there. Excellent. Yeah, this is a small update about it, and you will see it mounted and in the next test. All right, I'm not sure how I will be able to film this. So that is plugged in there. This is the wire here, and I put it here in the vise, in my mini vise here, which I love it. And let's see if I can do this with one hand. I'm not sure I can really do it, but I will try. Let's see if I'm lucky. I am lucky. Come on. Come on, baby. Come on, baby. 3 volts you should show me. Come on. Yes. Yeah. Yep. 3.4, 3.2, like that. And yes, it is. Actually, it is working. I made a mistake. I made a little mistake. So let's take it out from here. Let's take out this wire from here. This is a wire from some very extremely old, probably vintage now, headset. It was having this kind of mono audio plug. Yeah, I believe it was only one ear plug, only single one, not 2 of them, because it's having only 2 wires. And it was like yeah, it's very extremely old, probably from the 80s, even 70s. I will go there. This wire, and it's extremely soft. It's very soft. The plastic is preserved extremely well, but unfortunately, as you can see, the color degraded over time. They tend to get darker and more yellowish. And this was also having a tint or something in it. Probably it was white. This plastic probably was white, but it became green. So this, I hope I can do it with one hand. I don't think so. So now I can operate good enough. So I have to drag because this has catch there very well, which is good, but it's hard to take it out. I made a little mistake previously. and I put come on, focus, and I put so I managed to link it here. Let me add the light a little bit here. I managed to link it here very well, actually. I'm not sure if you can see that pin there is the plus 5 volts, and there is another pin here which is the ground. Yeah, it's hard to show with one hand, but I bent them directly, one on the pin and one on the pad there, where the red wire is going there. You see the copper wire is going there. There is the minus. I've also added a label here to be a bit more clear what is going on. So from the board itself I'm getting 5 volts, but from this thing I'm getting 3 volts from the voltage regulator. And I had a little a mistake. I put this resistor from here to here, and I wasn't getting the 3 volts as expected. And then I rechecked the diagram there, and I compared it with what I have here. Oh boy, and I made a mistake. But nothing burned, nothing exploded, everything is fine. Actually, it's very good, and I like it. And yeah, next I will. I also, as you can see probably, this diode is very thick, very big, and it's having this leg that is like an anchor for my wire here, not to be dragged, because you can drag the wire from this weldings, solderings, and it will rip apart those connections there. But being knotted like this here, it will drag from here and not from those connections, those very fragile connections. So it's a good idea to have an anchor like that there. So pretty much this is it about this voltage regulator hack. Well, 5 volts power supply traveler hack. I hope you like it. And pretty much this is it. The 5 volts is coming to here, and the ground here. And on the other side of this regulator is coming the 3 volts and also the ground, which is common. And I put a wire here and another wire here. I didn't put this capacitor there. Well, let's hope it's not that important. Usually it is a filter capacitor. And I hope I will not have problem. And next I will want to add a LED there, a signal LED that is plugged in, and probably I will take the LED, I will put it over the 5 volts here, or even from the 220, but it's flickering on 220, like this guy here, or that guy there as well. Alright, this is it for this part. I hope you like it, and yeah, see you later. Alright, there it is. I put a LED on it. I'll show you it in a second, but right now let me show you the proper voltage that I'm getting. 3.0504. It's absolutely perfect, exactly how I want it. All right, now I'll put this aside, taking it out. Come on. And showing it if I can take it out now. This is a challenge, how to take it out from here. It's a very good catch there. And I'm dragging from this side for a... Come on, yes, like that. They are catching extremely well there. So this is how I made the connection. Like I said, over... Let me actually draw it for you really quick. Over the 5 volts, I put a resistor and an LED here, and that's it. And this is it. Let me point it with my knife. The longer leg was the positive already, and it was having a very short leg here from the negative that I put a resistor there. Let me actually show it. Hopefully you can see it better. Yes, so you can see that. Yeah, you can see 1 kilo I put there, and I kind of make it work. You know, I make it. I fit everything to make it work, and it is working. Now all that remains is to make a hole in this case, in this lid, for the LED to come out from it, and this part is done. Yeah, this part is. I'm really happy so far. All right, and if you wonder how I managed to make this very precise hole here, this is how I did it. Let's see if I can film it. I put it like this. I don't think you can see the markings. No, you cannot. I put it like this, and from the top, I look from the top and I dragged very fine lines like that, pack and pack, and then I put it here, like I'm putting it right now, like I'm holding it right now. So the same line, in the same line here with this margin here, and then I dragged 2 other lines like that from the 3 millimeters with it like that, and then I made the square, and that was the point where this LED was, and this is it. It's good to have a good standing point there, and it's right on the money. And now if I plug it in, ta-da, it's very cool. I really like it. And the blue and on the white is very good as well. And here are the 3 volts, and this is it pretty much. All right, yeah, it's taking a little bit for the capacitors in there to discharge, but now it's safe. All right, this is it. All right, so I open it, and I've added I made a hole here. Oops. These buttons aren't going out. I managed to make a hole here like this. I measured the wire, it's 2.5 millimeter, and I made a hole as 2.5, exactly the width of this wire. And then this is minus and this is plus, but this here is a capacitor that wasn't put there. It was only the marking, but it wasn't any kind of capacitor there. And I put the continuity meter. I figured out this is minus and that is plus, so that capacitor was pretty much on the minus, the positive on the negative of the power source there, and they didn't include it. So lucky me, I dragged the wire from there because it's better from this side, and pretty much this is it. I've also put this isolator, blue isolation sticking band there, because there are vias, like little holes there, like those little holes, and my wire here is not perfect. It's having a little bit of wire remaining until the isolation, the plastic isolation, so I didn't want to risk touching one of those vias that I don't know where they go, and I probed them, and they don't relate to the negative or positive, so they are from other parts of the circuit. So pretty much this is a bit more proper way to do it. I don't like to drag wires directly in the middle of the board. This is very bad when you have to put it in the middle of the board, but I had a history of blowing up something which I highly regret, and it was expensive as well. And I learned my lesson from back then. And yeah, this is a relay here, this guy here. These wires are weird. This black wire is actually the plus, and they say there is minus, the negative lead, but minus lead, but this is actually the plus wire, because that point with the plus point, they is the same track. So it's very weird. Well, I will see. But the red wire doesn't doesn't show on the continuity that is on minus. So is interrupted by those transistors that are there. You can see them. So pretty much this is it. Yeah, I can make you a test right now. Let's see. This guy is beeping. Let me insert these buttons to show you the light, if I can, with these wires in the way. So pretty much, can I do it? Yes. And yeah, you can see it. And if I'm holding, yeah, the light are getting in. So yeah, we have Houston, we are in business. So right now, I actually took out all this board to see, to check those LEDs there, but it's a bit hard for me, at least, to work on them. So let's take it out. So I observed these 3 wires here, these 3 wires that are going on that board, and most probably they are powering the LEDs there. There is a pink, is not showing here. It's a rubber band that is connecting to the display. A very large, long rubber band with connections, and those connections are actually making the display functioning. But these wires are, and it's curious that there are 3 of them. Probably they are on one side, and on the other side, 2 sides. I'll have to test to check exactly what they are, these wires. But this part with the power, the power wire, power cable that I made here, and with the power supply is absolutely awesome. Yeah, I am happy about it, how it's coming out. I hope I will not fuck it up. Oh, yeah. All right, see you later. All right, well, I made some very interesting progress here. I took out the wire. I desoldered the wires from those positions. I've also took a picture of that location, and I also made a little note here where everything was how it was like before. And I discovered a hidden function that I don't think I knew how to do it from the software. I believe they included this new red LEDs, but they didn't include in the software or the thing. So what I did, this is the positive lead. Here is 3 volts. There is 3 volts, and I've looked on the here. Where are you? My knife. So pretty much, I know you cannot see very well at this distance, but I will tell you. These are the points, the 3 points. These wires were soldered, and only here and here are 2 resistors, and those resistors are going to these pins of the transistors. These 4 black guys here are 4 transistors, but these 2 guys are for controlling the LEDs. Now, these resistors are 51 ohms. 51 ohms. I double looked with a magnifying glass on their marking there, and that's how I discovered 510 is the marking on both of them. So I took, if that is 51 ohms, I took 100 ohms, which is limiting a little bit more. I already established this black wire is actually the positive wire, pretty much. And check it out. Check this out. The white. And this is the hidden function. Probably these wires actually represents the code, the color, represents the color of the LEDs. Very, very weird. So the white wire represents the white LEDs. Check this out. And the red wire represents the red LEDs. Come on. And it's consuming 20 milliamps. It's showing on my, yeah, it's not making connections very well. Yeah, like that. So pretty much, right now it's not powered at all. I'm only checking the LEDs from outside, pretty much. So this is the red display, and this is the white display. Unfortunately, I couldn't reach that that side where the LEDs were. I wanted to kind of be able to change them to put better LEDs, but yeah, it's good enough. It's good enough as it is. So this is it. This is the test that I made right now. I have another another light as a red light. Probably that red light is when yeah, I believe I know what that red light means, signifies when is a problem, is turning off the white light and it's putting the red light. Pretty interesting. When is a problem, when is a short or something, who knows, only he knows, only his software knows. But what I'm interested is the white light. Come on, yeah, I'm not making contact very well here for some reason, although I'm putting directly, maybe like this. Yeah, the alligator clip was biting on the, not on the metal, but on the paint there. Yeah, and now it's very good. Let's see if I'm putting them together. Are you going together? Come on, you should. You should. You don't like it, huh? You don't like it. Yeah. Okay then. Are you working? Are you still working? Yeah, some yep, it's working, but with some kind of interruptions. I've noticed this wire was pressed extremely hard here by something when they assemble it, and there's you see, yeah, that is touching there. So pretty much this is it. Yep. Next, I will make a switch that will power directly this wire, these 2 wires, the white wire, the white LEDs, white wire and black wire. They will be connected directly and to the power supply, and probably with its own resistor through a switch. That's the idea. But I wanted to show you how it's looking so far. I hope you liked it. Thank you very much. And believe it or not, I made it work. I tried. I made it work with a switch to light to put on the light. So let's plug it in. There, and is staying already as the switch, you know, is pressed already. So it's commutated directly right now on the switch. It is not commanded by that microprocessor bullshit timer fucker motherfucker. So pretty much what I did here, I actually tried a lot of ideas. Let me show you. I tried the jumpers initially. After I discovered that red light, I wanted to include it as well, but it's more like it's not practical, not really. So right now the red light is not available. But I have installed this option to turn on the white light all the time, as long as I please. But instead I don't have that red light, which I don't give a fuck. So initially I thought to put 4 pins like this, and put that jumper on each two, something like. Let me do it very quickly. So 1, 2, 3, 4, right? So this in the middle will be the common, and I will put a jumper here, then here, and switch between the lights. So this is plus, let's say this is plus, common plus, a positive, and this will be negative for the white, and this will be negative for the red. And when I'm switching the jumper from one to another, it will switch the lights. And here, this is unconnected, so not connected, you can see. And when I will put the jumper here, nothing will work pretty much. It will be in the off state. But I tried it. I really tried it. But I have so little space here. Let me show you. You can see there is a hole, the fourth hole. This switch is having 3 pins on it. Yeah, you can see it from here. And I couldn't make stable the pins. I couldn't make them stay fixed. They were wobbling, they were moving in all directions. They were like shit. And if I was dragging the jumper, which is pretty pressed, is fitting very well, very pressed, it was dragging the pin out, and no. Right now what I did here, I inserted the pins of this switch inside, and then I bent them up. You can probably see a little bit there how is something a little tiny bit up. That is a little bit of the pin of that switch. And from those pins, 2 pins, I put this. I put a 47 ohm resistor. I believe you can actually see it. Yes, like this. So you can see it's written there 47 ohms. And I put pretty much this wire to minus. This wire from 1 pin, and those 2 pins to a resistor, and to one the negative. This is actually. This is the negative, the white one. The white wire is the negative of the LED, and the black wire, and this black wire is the positive, because it's Chinese. That's why. I'm telling you what they think. Nobody will actually open this, so we can put black wire as a positive, you know, and the red wire we can put it as negative. Because nobody will look inside. Come on, be serious. That's how they were discussing there, you know, and they were laughing as well, like me here. So this is the positive, the black wire, which is there on the positive of the LEDs, and this white wire is the negative of the LEDs. So pretty much the current goes through LEDs, is coming back from LEDs through this resistor, then through the switch, and then to the negative rail of the circuit of the board. So pretty much this is it. Very, very simple to do it. I mean, very simple as an idea, but a bit hard to implement it, because it's a mess of wires. It's not pretty at all, and I'll have to fit this wire as well back there as it was before, and it's pretty much done. It's not pretty, but it's functional, and when I will close the case, yeah, it will be okay. So missions, I will not say completed right now, because I still have a little bit of work to do, but in the end I will show you the final product. Thank you very much. All right, it was a bit hard work, and a bit dangerous work. Dangerous in the sense that I could break it or do something stupid. But is done. Is finished. Project finished, and is working exactly as I wanted. And look how easy and practical right now it is. So when I'm plugging it in, it's starting automatically. Is remaining on the last setting. Let me close the lights here. So it's remaining on the last light setting that I switched, which is absolutely super. Before, look, he's counting some hertz there. Some frequencies. Yeah, I know there are some stuff in my room. But hopefully it doesn't sense this wire. Yeah. The thing is that before, how it worked before, I can simulate, actually. I can simulate how you had to turn it off. Let's switch this off. So this is how you had to turn it off and on. From this bullshit button here, you had to when you click once, it was opening, but if you click once, doesn't close. You had to keep it closed for about 3 seconds, and is absolutely bullshit, absolutely bullshit. And right now I can use it like this as well. And let me open it actually, like that. And the of course right now the lights are not working from these buttons, but you had to do it like this. You had to go there, and you had to guess which one was the light. It wasn't. Yeah, it's no. I really didn't like it. And then after a couple of seconds, I don't think. I believe 30 seconds or less than 1 minute it was, and the lights were switching off automatically, and you had to go back and switch it on, and it was announcing you too much power consuming. It was beeping, and then switching off the light, and it was horrible. I really disliked that function. So right now is direct on 5 volts all the time. I can keep it as long as I want. Also, I almost forget. After 5 minutes of staying on, it was automatically turning it off automatically. So if I was letting it on the table, even if I was working or not working, it was automatically turning off. It didn't sense the fact that I was working. And actually this was one of the causes that irritate me enormously. I was working actually, and this fucker turned off. No fucking way. It's no, it's not right. It's not right. So I put it on direct pretty much right now. I see right now I have some fluctuations here for some reasons. I didn't have this hertz reading. Probably it's on a setting, weird setting here. If it's even pressing. The problem was the button. Instead, the button, the plastic button that is here, pressing on the button component that is inside on the board. So this is the button on the board, and my hand is the plastic button. It was on the button like this instead of being near the button to actually press it. So I couldn't press the button. It was a little bit of a hiccup when I mounted it, but now is absolutely fine. And it was a little bit of was running around. It's probably a bit too sensitive right now. I increased his sensitivity by adding this wire here, probably from, but is correctly at 3 volts. Is fine, and probably some wires inside it are near some sensors there. Yeah, but it's fine. It's fine. It's okay. He's doing his job there, whatever he wants. But pretty much this is it. I'm really happy with it as it is right now. Very easy, extremely easy to switch on off, and not being afraid of turning off like an idiot, literally like an idiot. Right. Thank you very much for watching, and I hope you liked my little hack that I did here. And leave a like, and see you later, alligator. Bye bye.